Hey guys, welcome back. So today let's see like how to design a highly available three-tier system on Kubernetes. Okay, so this is one of the important questions in interview. Okay, so they may tell you to design a highly available system so that it will be available all the time, and what are all the different components involved in this design. Okay, so in case if they ask you to design the thing, so you can tell this. Okay, so in case if you are to design a highly available three-tier system, so the different things which are involved are like it should have the reliability patterns. Okay, it should have the reliability patterns, and you should show the deployment manifests, and then you have to show the CI/CD involved, and also the failure scenarios. For example, if there is some failure, how would recover that one. Okay, so in case of three tier, so actually it involves three layers. Okay, so one is front end, so where the end user will access the application, and backend application. So in case if he is querying for some data or something, so the front end will contact the backend, and then from backend we'll get the data from the databases. Okay, so this is the three-tier architecture. Okay. So what are all the components involved in this? So the first thing is ingress controller. Okay, so for example, you can take in Nginx. So what exactly this ingress controller will do? So actually, it will control the incoming traffic. Okay, and we can have cert-manager as well for TLS security. Okay, and then we should have external load balancers so that the load will be distributed equally, and we will have Prometheus and Grafana for monitoring and alert manager. This is also one of the important thing because once we deploy, so we should know in case of any issues, right? So Prometheus and Grafana is important, and we also need to configure FluentD, Vector, or Loki for logging the details. Okay, and also we should have Argo CD in case if it is Kubernetes because it is a GitOps tool, and it is very convenient in managing the Kubernetes. Okay, and we can also have some service mesh so that it will also help in splitting the traffic, and also it will enable the mutual TLS across the cluster. Okay, and what is the high availability pattern? So in case if it has to be highly available, so multiple replicas per tier. Okay, so we should have multiple replicas. So it can be 3, 5, 7, whatever it is, based on the load and based on the users, you can increase the replicas. Okay, and we should define the pod affinity. So when you have multiple availability zones, you should have like node affinity set for the pods. Okay, so that each pod will be deployed in different availability zone, that even if one availability zone is having some issue, the other one will serve the data. Okay, and pod distribution budget should be set. What is pod distribution budget? So a minimum number of pods should always be running no matter what. Okay, so those configurations will be defined in the pod distribution budget, and we have to define the readiness and liveliness proof. So when the pod will be ready and when it will ready to accept the traffic, those things are defined here. And stateful set with at least one replica for primary plus replicas. Okay, so stateful sets should have at least one replicas, and we also need to use storage class so that we will be able to define PVCs, and we will be able to store the data. Okay, and also we should configure the backup with Valero or any other tool, so that what exactly it will be helpful. So it will be helpful in taking the backups daily. Okay, daily or whatever frequency you need, you can just configure that one, so that all the HCD and all the important data will be backed up in case of some disaster. You will be able to recover from this. Okay, so what should be the topology? So it should have at least three worker nodes across two or three availability zones. Okay, so why it should be spread across multiple availability zones? So in case if there is some disaster in one of the availability zone, the data can be accessed from the other availability zone. Okay, and control plan should be managed by EKS, GKR or something. In case if you are managing it, just configure the higher HA, and you also should be deployed across multiple availability zones. Okay, and node pools. So based on your requirement, you can just create the node pools. Okay, and in case if you have to manage multiple manifest files, you can use Helm chart. Okay, so you can configure all this front end, back end, everything using Helm charts. And what should be the configuration for front end? You can configure the front end, and for back, and also you can configure the back end, and you should have a service to connect them, right? So that one, and then you have to configure a database for saving the data. Okay, so those things, and all these things should be exposed in ingress, and you should configure the routes. Okay, through the APIs, so how it has to be accessed. And for reliability and safety, you have to configure these things: pod distribution budget, horizontal pod accelerator, and resource requisition limits. So why this is important? Because in case if you're not limiting the resource consumption of a pod, it may end up eating the entire memory of the cluster. Okay, so it is always recommended to use the request and limits. Okay, and the readiness and liveness probe, because in case if the pod is not ready and if the it starts sending some queries, and it may return some errors, right? So in order to avoid that one, you have to configure the readiness and liveness probes. And network policies, to restrict the users, you have to use the network policies. Okay, and these things. Okay, now let's see it in diagrams. Okay, so I'll just drop this one. Okay, so now let's see like how exactly the end-to-end flow will be there. Okay, let me select this one. So what is this? This is three-tier high availability architecture. Okay, instead of this, I could type it actually. Three-tier highly available architecture. Okay, so how we can design? So first is always, in case if you have an application. Okay, in case if you have an application, the first thing is we should have the users. Okay, they should access the application. Okay, we have a user, so he opens his mobile or laptop. Okay, and then he goes through a website. Okay, for example, your application is https:/myapp.com. Okay, so this user hits this website. Okay, so what exactly it will happen? So it will go to the ingress. Okay, so for ingress we have configured the nginx ingress. Okay, so it will go to the ingress. So ingress will once the user hits this website, it will go to the ingress, and then once this receives the ingress, then it will also have the set manager. In case if we have installed set manager, so it will check TLS certificate. Okay, whether the certificates are valid for the browser and those things, it will be configured. Okay, so once this is done, this will be routed to APIs. Okay, so for example, if we have root as front end. Okay, and then slash API for backend. Okay, so these are the applications. So obviously the request will go to front end. Okay, here we have the front end. Okay, so what exactly it will happen here? So the front end will have multiple parts. Okay, so this front end, it will not be one application, it will be like multiple applications, multiple parts. Okay, like part 1, part 2, part 3. Okay, so multiple will be there, and the load will be distributed equally between different parts based on their availability. Okay, and these parts are scheduled with anti-affinity. Okay, so it should be configured at different nodes and different availability zones. Okay, for example, this part will be in az1. Okay, and this will be in az2, and this will be in az3, availability zone 3. So what happens? So for example, this in US East 1. Okay, US East 1, and this one is US West 1, and then this one is US North 1. Okay, so for example, something happened in US East 1. Okay, then the traffic will be served from these two parts. Okay, which are in different availability zone. Okay, so that's why we need to have different availability zones. And what is the other thing which we have to set here? So what exactly we have set now? So we have set like here we have set anti-affinity nodes. Okay, anti-affinity nodes. So we have set that one, and then we have to configure the readiness. So we have to configure the readiness and liveliness. Okay, so that the data, it will not be sent unnecessarily to the parts. Okay, so once this is done, so for example, this front end, we have this front end. So for example, let's assume this as Amazon. Okay, so if you go to Amazon, you have logged in. Okay, so the user has logged in into amazon.com, it will go to nginx ingress. So it will check whether the TLS is proper and so then it will go to Amazon front page. Okay. So once that is done, so it is available across multiple availability zones. Okay, this is fine. Now this user, let's assume he looks for iPhone 17. Okay. Now the user looks for iPhone 17. Okay. So this iPhone 17 is available in the backend tier. Okay. It is available in the backend tier. Okay. So, okay. So this front end needs data from backend. Okay. But how does it come here? Okay. So in between, we will have something called service. So we will have service routes to one or several backend pods. Okay, this service, it will send the data to this backend. So in this backend, you will have multiple parts. Okay, part one, part two, and part three. Okay, so multiple parts will be there, and it will be distributed across multiple availability zones as well. Okay, and also we have to configure HPA. Okay, horizontal pod accelerator. So how this horizontal pod accelerator will be configured? It will be configured based on different things. Okay, so based on CPU or request metrics, or CPU or request metrics. Okay, so when the CPU requests increase beyond certain limit, then it will try to increase the number of available pods. Okay, so if a pod or node fails, Kubernetes will reschedule while pod distribution ensures. So what exactly we will do? So we have also configured what? We have also called PDB, pod distribution budget. Okay, so what is the use of this one? For example, if you are doing some update or something, then what it will happen, it will ensure, like one, for example, if we have three pods, it will make sure two pods always running. Okay, so two pods always running, only one pod will be updated in case if you are doing some update. So these pod distribution budgets will be always configured in this pod distribution budget config. Okay, so so we have this backend tier. So in the front end, the user is in front end, the user is looking for some iPhone 17. So front end will access the backend using a service, and it will be distributed across multiple parts. Okay, now the data, so these parts are configured with HPA, horizontal pod accelerator, so that based on the request on CPU, it will try to increase the number of parts or reduce the number of parts based on the traffic. Okay, and these HPA parts are also configured with PDB. Okay, part distribution budget, so that minimum number of parts are always available. Okay, the actual request is iPhone 17. So backend tier, it will just try to create parts and manage access to these databases, right? So what exactly it will happen? So the backend connects to Postgres. Okay, Postgres or whichever DB you want, it will be connecting to that. So this backend, it will connect to DB. Okay, so for example, let's consider it as Postgres. Okay, so it is a stateful set. Okay, it is a stateful set. Okay, so what exactly is stateful set? So always it will have the names like Postgres 0, Postgres 1, Postgres 2, and in case if the data is there here, it will sync with 1, and the data in 1 will sync with 2. Okay, so even when you delete, it will be deleting in a sequential order, and when you create a pod, it will be created in a sequential order. Okay, and what is the main advantage of this one? So all the parts, it will be in a sync. Okay, so there will not be any unsynced parts. So all the parts will have the same data. Okay, so this is called stateful sets. Okay, so all the DBs and Kafka, all these things will use stateful set. Okay, so this is the so this Postgres will have the details about this iPhone 17. Okay, this iPhone 17, again, it will send data to backend, backend will send to front end, and front end, it will display it to the end user. Okay, so this is how. Okay, so once this is done, okay, so we have multiple components. So we have multiple components here. So we have configured multiple components. So this is like one Kubernetes cluster. So here we have just seen some three pods, those things and all, right? For example, we have, oh, let me increase the size. So let's assume we have 100 pods. Okay, let's assume we have 100 pods, or else we have some 1000 pods. So we can't log into each and every cluster and able to check it, right? So what exactly we have to do? We have to configure the observability. Okay, observability. So how we can configure observability? So we have to configure Grafana and Prometheus. So you can use any tool, like we will have multiple tools like Datadog, or else you have like different monitoring tools from different cloud providers. You can use anything. So Grafana and Prometheus are quite popular. Okay, because of that I am pointing to this one. So what exactly is Prometheus? So Prometheus will have the queries, okay, called promql. Okay, it will have the query language called promql. So it will query each and every Kubernetes cluster. Okay, so this Kubernetes cluster will have something called exporter. Okay, so this exporter will send data to Prometheus. Okay, so in case if you have to see that data, you can use promql, and you can query that query. Okay, so you can send these queries to Grafana, so that we will be able to visualize. Okay, we will be able to visualize. Okay, so Grafana is a visualization tool and Prometheus is a uh, querying tool. Okay, so you have to do this one, and we have these different parts, and we will have different logs, right? Because in case if you have to um, debug something or you have to do something, you should have logs saved for long term. Okay, so in case if you have to have that one, so what exactly you have to do? So you have to define the logging system. Okay, so what exactly this logging system will do? So you have to enable the logging. Okay, so how you can enable the logging? So you can configure like different tools. For example, you will have fluentd. Where exactly is this? So you have different tools like fluent d, or else we have something called vector. Okay, and also we have something called Loki. So what exactly it will do? It will save the logs, and then based on your requirement you can query this one. Okay, so this is like very helpful in case if you have to debug. For example, something happened at a particular date and particular times. Okay, so if you have to see those logs may not be available in your Kubernetes cluster. Okay, but those things will be saved in this logging system, so that you will be able to access those and you will be able to provide it to the end user. Okay, so it will be very helpful when you want that one. Okay. Okay, so you have enabled the logging. Okay, so you have enabled the logging. Now we have one more thing. So what is this? So for example, you will have multiple services, right? For example, you will have multiple services, and then if you have to enable service to service communication, so we will have service for front end, we will have service for back end. So in case if these things have to communicate and if you have to design, so you can configure what you can configure like istio or something. Okay, you can configure istio or something. And also what is the advantage of that one? You can have mutual tls enabled. Okay, so that it will encrypt when the data is in transfer or something. And also this will be very helpful when you do the deployments. Okay, when you do the deployments, it will be very helpful. Okay, and how the deployment lifecycle? Okay, so now you have explained all these things. Now you have to tell them like how the deployments are done. Okay, so deployments can be done using different things. So you can use one is you can use Jenkins. Okay, so Jenkins is push based method. Okay, push based. So this is not recommended much. Okay, because for Kubernetes, in case if you are using push based method, uh, like in case if there is some drift or something, you will not be able to identify. So always you go with GitOps. Okay, so GitOps is pull based method, pull based. Okay, so here the single source of truth is git. Okay, so whatever configuration you make in git, so that will be considered as a single source of truth. And so in case even if you change something or do something, it will be automatically record back. Okay, so always try to use these GitOps tools. Okay, so Argo CD detects changes and it will sync them automatically to the cluster, and therefore so always the git will match the cluster's required state. Okay, so this is the things. So these are all the things which you can explain for a highly available environment. Okay, now let's see the failure scenarios. Okay, so failure scenarios. So, for example, if node fails, okay, for example, we have configured the Kubernetes cluster and it has multiple nodes, okay. So we have the Kubernetes cluster and it will have multiple nodes, okay. So for example, if node fails, like pod should reschedule on a healthy node. For example, if this node fails, it should reschedule on the healthy node, okay. So by that way, like you will be able to serve the end users, okay. And db fails, for example, if db fails, like operator should like for example, when you use db, try to use operator, okay, db operator, so that in case if something happens, it will try to automatically switch or create a new replica in the other things, okay. And for example, so one is node failure, okay, and another is like db failure. So for example, we will have multiple DBs. Okay. So we have seen, right, in stateful set, we will have multiple things. So in DB, we will have multiple things. Okay. So for example, if you see, so we will have multiple parts and each one will have the numbering in 0, 1, 2, 3 in a linear manner. Why? Because all these things will be in sync. Okay. So for example, if any of the one fails, okay, for example ps0 fails, the ps1 will serve the data because it will have exactly the same data which was there in the ps0, okay. So if ps0 fails, that is not an issue because this ps1, ps2, ps3, everything will have the same data, okay, so that you can create a new pod and the data will be replicated, okay. The next thing is, for example, if we will have different certificates, right? So for example, if a certificate failed, like expired, so you should renew that one. So you have to like make sure that you automatically renew that certificate so that it will be always available, okay. And also, like if high traffic, for example, if hpa scales out and backend parts, so for example, if it is beyond its criteria, so you have to do all the load testing before deploying the application, okay, so that you will be able to make sure that the required infra is always available, okay. So what are all the things we have seen? So okay, so the user access the website, it will go to the ingress, okay. So for from ingress, you will have the set manager so that it will verify the tls certificate and it will go to the front end, okay. So front end, it will have different parts and it will distribute the load. So what will happen? So it will be deployed across multiple availability zones so that even if one of the parts goes down, other will serve the traffic. And then when a user requests something from the front end, it will go to the back end, okay. So back end will have multiple parts and all the HPA, horizontal pod accelerator, and then PDB, everything will be configured here. Okay, so based on that, the backend will query the DB. Okay, so the DB will have the stateful applications configured. So what exactly it will do? So it will always maintain the replicas and all the pods will have the same data. Okay, so for example, we have configured everything and it is for one cluster. In case if we have like hundreds of clusters and thousands of parts, so we have to configure the observability. We have to configure Prometheus and Grafana, and for Grafana is for visualizing and Prometheus is for querying and this one. And we have alert manager as well to send the alerts, okay. And then we will have multiple logs in this Kubernetes cluster, right? So we can use some logging tools like Fluentd, Vector, Loki, or something. And for deployments, we can use Jenkins or GitOps, but I won't recommend Jenkins. So always go with GitOps tools, anything like Argo CD, Flux, anything, because it is pull-based model and it will be very helpful in pushing and managing the state of the application. Okay, and finally the failure scenarios. Okay, so if a node fails, so part should be rescheduled to the healthy node. So why, how it will reschedule? So we have to configure the replicas and anti-affinity. Okay, and if DB fails, for example, if a DB fails, so we can make another replica is created because all the replicas will have the same data. And also we have to make sure certificates doesn't expire. Okay, even if it expires, it should be automatically renewed. Okay, and also in case of high traffic or something, horizontal pod accelerator should be configured with the required amount of infra, okay, because in case if you don't have enough infra, then it may fail, okay. So this is what you can explain, guys, for high availability, okay. So that's it for today. So let's catch up in the next class. Okay. Thank you. In case if you like the video, please like the video. Thank you. Bye.